I have great news. Now, you know what you're thinking. Good news in a low-level TV video? What's going on here? Now, I know you're probably thinking, oh, my monkey brain craves rage and outrage, but no, this is actually a really good thing. We're talking about the NPM situation, in particular, the supply chain attacks that have been going on for what feels like thousands of years, okay? The Shai-Hulud worms and the Team PCP may have met their maker. A new feature by GitHub is going to make our lives a little bit better. Let's talk about it. We're talking today, guys, about a solution potentially for the Shai-Hulud problem. If you're not aware of what Shai-Hulud means, Shai-Hulud itself is a worm from the Dune universe. But here, Shai-Hulud is a word that refers to a worm that has been compromising the NPM ecosystem for multiple months. Coming up to, I think, like June of this year, there was another attack, and it goes back all the way to like October of last year. Only a few months, but it feels like an eternity in the cybersecurity world. NPM, if you're not aware, build amazing things, including self-propagating worms, which is pretty amazing as well. NPM is the node package manager for the JavaScript ecosystem. I'm stumbling over that word because I don't code in JavaScript. I don't really believe in it. Shai-Hulud has been rampaging the NPM ecosystem, dropping a variety of malware that will replicate itself by stealing credentials to push more malicious packages up to NPM, and then using that to run all over the internet, run rampant. It pulls down credentials. It steals things like AWS tokens, GCP tokens, and Azure tokens. But how does it propagate? How is it possible for this to just happen through running a simple npm install, which is how all these run? Well, there has been a feature for a very long time on npm called a post installation script, right? So when you download an npm package, what are you doing? You're installing code that somebody else wrote because you don't want to write how to pad a string. You don't want to write is even. You want to download it from somebody else because it's too hard to write it yourself. Fine. This is the majority of coding ecosystems now online. You have JavaScript is like this, Go is like this, Python's like this, and it makes life for a developer a lot easier. Well, a lot of these packages, unfortunately, they have to do something that's like native on the computer. They maybe have to have some kind of way to build something after it runs. How do you do this? Well, in the NPM ecosystem, we have this thing called a post installation script, which literally is just a shell script that runs on your computer. Sounds pretty good, not a big deal. Here's the issue with the post installation script. If a malicious post installation script gets committed to a repository, an npm package repository, now anybody else downstream who installs that repository runs the npm install script on their computer. Not only that, it's not just if you install a particular package, it's if you install a package that depends on that package.
And if you want to learn more about the hacking campaigns that spawned as a result of the vast number of NPM supply chain issues, we can use today's sponsor, Flare. Flare Cyber Threat Intelligence is a tool that helps you and your analysts get the information you need fast, like active threats and indicators of compromise. Flare Cyber Threat Intelligence has a bunch of new features. One in particular that's pretty cool is the intelligence browser. You can take like the hash of a file, for example, this is a SHA-256 of a particular file, we'll find out here in a second. And by going to the report on that file, we can actually go to the threat context associated with this file and see that this is an IOC for one of the many Shai-Hulud campaigns from October of last year. If we click in on the threat context, you go to the bottom, we actually get a nice little report about what the nature of the attack was, what the actor does, and kind of what their end state is, what their goal is in the compromise that they made. And Flare also has threat flow where they have their own reports with all the events they collect. They take these events and write up reports about the active state of the cyber domain. What are hackers doing on the dark web and other nefarious channels? Now, what you can do as a person who's doing maybe analytical work, you can type in a question to the threat flow and say, hey, what's the current status of Shai-Hulud? Question mark. And after a few minutes, you get a nice little report about the current state of Shai-Hulud, which actually includes a new IOC. It looks like Claude at users.noreply.github.com is being used by these actors to do their exfiltration, which is kind of interesting. And good news, if you want to try Flare Threat Flow, you can try it right now for free at this URL. Go give it a shot and see what you can find hiding in the Intel buckets. Thank you for sponsoring the video, Flare. Let's get back to it.
I want to highlight Mr. Koba real quick, by the way. W Koba in the chat. 2019, what was that, 7 years ago? Koba's like, hey, install and post-install scripts are npm scripts that run while npm install is running, or npm CI, which is definitely dangerous if we don't recognize what packages are installed as dependencies. And this basically went like ignored for 2 years initially. And then basically, I think in July of this year, it caught some attention with PNPM saying, hey, we implemented this. And then eventually this guy being like, yo, by the way, in February, Shai-Hulud got around the npm ecosystem explicitly because this feature feature didn't exist. So props to my boy Koba. I'm sorry this did not get more love. For example, if I were to install the package Axios, right, which is a repository for doing HTTP requests in the front end of JavaScript, and I know there's the whole Axios versus fetch argument. Silence JavaScript developers. A vulnerability researcher is talking. So, but if I install Axios, if Axios has a post-install script that is malicious, it will get ran. Not really a big deal, very unlikely because Axios surely would never get compromised. But here's the thing, Axios, like any JavaScript package, has some dependencies. So that maybe if Axios gets compromised, if this package gets compromised, or one of its dependencies, or one of its dependencies, or one of, okay, we got to the bottom of the tree finally. But if this random package that was published 6 years ago, if it had a malicious post-install script, me running npm install Axios would also get popped. Not a great thing. Enter GitHub. And yes, I know, like we've been talking a lot about how GitHub is making a couple of L's, a couple of uptime issues. Let's go and check on our buddies at GitHub real quick. Let's see. All right, how's our uptime doing? Let's see. Okay, it's looking pretty good. Anyway, GitHub came up with a change. Our next NPM major version, version 12, introduces security-related default changes to NPM install. All these changes are available behind warnings in NPM today on 11.16 or newer. Each change turns an NPM install behavior that automatically runs today into one you explicitly opt into, which means allow scripts which is defaulted to off. Pre-install, install, or post-install scripts will not run by default in NPM version 12. Guys, this is like a really big deal. This is actually tremendous for the industry. Like this, not that it will stop self-propagating worms, okay? Not that it will make them all go away, but this is a huge push in the right direction for the world of supply chain security. Also, allow Git. This will default to none. What this means is that a malicious npm RC can't override the Git binary to run a different binary that also can be located locally in the repository, which again, huge W. And then same thing, allow remote. npm install will no longer resolve dependencies from remote URLs, such as an HTTPS tarball, unless explicitly allowed by allow remote. This flag is available in npm 11.15+. Huge deal. Guys, this will completely change the game for supply chain security. We love it. Now, one issue with this and one maybe potential argument you may have is npm is literally a way to take code remotely and run it locally. Like, is not npm on its own remote code execution, like as a service? You're right, that doesn't really go away here, but there's some caveats that make this way more secure than just the way things are currently. There are kind of two places where Shai-Hulud really hit. One is obviously like the developer laptop, right? Like you're on your laptop, npm install a thing, and boom, now you're compromised. And maybe you as a developer are a maintainer of a package. They take your npm push token, your OIDC token, and you use that to publish a new malicious repo, and that kind of self-propagates over and over again. That's the one scenario. But the second scenario is where it gets a little more spicy, okay? Don't forget, there's this whole world of CI/CD, continuous integration, continuous delivery pipelines that are basically automated ways for maintainers and developers of software to not only build and test their code, but also to deploy it, okay? When you do a CI/CD pipeline, a lot of the times, those CI/CD environments run npm install, and then after they run npm install, the malicious post-install script is now in an environment where that environment might have access to a GitHub PAT, a personal access token for that repo that now gives the attacker the ability to push to that repo through compromising one of the dependencies that it uses, right? There's a whole world of automation that the pre, post, and install scripts all compromise. By getting rid of them like this, it makes things a lot easier. Also, on the comment about this being just general RCE, even though you download Axios, which may use a package that gets compromised, in the case that it's not post-install scripts and it's just a piece of malicious code in the module, to actually execute the malicious code, you have to import one of the modules and run it. You have to acquire the module inside of that module and then run some kind of function inside of it. Now, from a blast radius perspective, if this is a function that a lot of people use, when the commit is made to the repo, it will get a lot of eyes. It will get a lot of comments and it'll get a lot of review. And so the ability for you just to like commit to Axios get, right, Axios post and push malicious code there is much more difficult. Not impossible, but definitely obviously much more difficult. If you are a user of the NPM ecosystem, I still recommend NPM introduces minimum release age. This is a setting in your NPM settings that allows you to tell NPM, hey, do not install packages that are younger than N days or N weeks. The reason for this is basically all of these compromises, right, of NPM packages have been caught on the order of 1 to 2 days or weeks, at most a week. I think some even getting caught in an order of like 90 minutes, right? So if you say, hey, I don't want to allow my packages to be younger than 1 week or 2 weeks, there's a pretty good chance this reduces the amount of damage that this could do to your ecosystem, right? That being said, obviously, if you're using some kind of like back-end package that you use in NPM and there's like a giant RCE vulnerability, right, where you can get hacked, maybe like some Next.js bug, okay, maybe we go and we properly patch that next version, right? I literally did this on a server of mine like yesterday. I forgot that I had a server running that uses like Next, 16.0.10 or something, and I had to upgrade it to like 16.0.12. That you have to fix. But, maybe if there's like a minor performance upgrade or there's like a minor like formatting change or something, maybe we don't update them immediately because of the potential of there being a supply chain issue. Doesn't happen a lot in security, but this is a pretty good thing. This is a pretty good day. So thanks for watching. Love you.